Namaste, Kushro over to you. Today's topic is the size reduction equipment grinders. There are three, four types of grinders which are popular in the food industries: attrition mill, hammer mill, impactors, and rolling compression mills. Attrition mill is also known as burr mill, and it acts on the principle of the friction. And what happens? There are two grooved flat faces of the rotating circular disc, and the food material, especially the grains, they are rubbed between these grooved flat faces of the discs, and the material that reduced in the size by this action of frictional force. And these discs, they rotate around a horizontal or vertical axis. One is stationary and another is the fixed. And the discs are mainly 20 to 137 centimeter in diameter and operates at 350 to 700 rounds per minute. Next comes the hammer mill. Hammer mill is a popular mill, and it is used for reducing the size of the food material or the food grains or even the spices into a fine powder. And it consists of high-speed rotor rotating inside a cylindrical casing. And because of the impact forces, the food material that reduced in the size, and that falls on a screen, and from that screen that comes out from the product outlet area. And in that casing, what is happening, this size reduction, as I told, is taking place by these rotating hammers. And you can see here, these are the rotating hammers, and these are the fine product screens. This is the screen from where the fine product is coming out. You can see again in this pick, the feed hopper is there, the material is being feeded. There's a feed screw which is taking the material in between the hammer and this casing, and from this screen the discharge is coming out, and the product is coming out from the product outlet. And hammers are rotated 1550 to 4000 rounds per minute. So that's how the size reduction takes place in a hammer mill. Now comes the ball mill. In ball mill, what is happening? The balls are there, and those balls give a impacting force, give an impact to the food material, and the casing is half filled with the balls. And those balls, they because of the centrifugal force, those balls, they are sticking to the walls of that casing. And when the ball mill runs, what happens? They drop from the top and falls on the food product, and because of the impact force, the food product reduces in the size, small size. So that's how the reduction takes place in a ball mill. And now there is an important aspect, that is of critical speed, rotational speed at which centrifugation occurs. And at this speed, no impact occurs and there is no grinding result. Operating speed must be less than this critical speed, and it is the speed that at which the balls, they are released from the mill wall, and they fall on the product, and grinding occurs. And it depends on the interaction of gravitational and centrifugal force. And critical speed we can determine by this small equation. NC with the critical speed is equal to half pi under root G capital R minus small r. So capital R is the radius of the mill, small r is the radius of the ball, and there are 1,000 number of ball. And this ball mill is very good. When you take a look into this, you will find the casing is half filled with the small stainless steel balls. So that's how the ball mill acts. I have added a video, recommended video, where you can see the action of the ball mill in place. That's all about today's discussion. If you have any question, you can mention that in my comment box on my YouTube, and I will answer it accordingly. Thank you.